Now, let's go ahead and wrap up Chapter 1 with Section 6, Math. Math is one of the tools of science. We have to work with it, because it is what's known as symbolic logic. You could spend 20,000 pages writing something down that you could express in just a few very simple phrases of math. That's why we use it. That's why you need to be able to work with it. Now, in these 2 semesters of chemistry, we're limiting ourselves to algebra. Calculus is a very powerful tool, and you can do a lot with it, but it's not absolutely necessary for this basic level stuff. That said, you have to be able to do algebra and arithmetic. That means, for algebra, you have to be able to manipulate equations. You have to be able to move things around so that you can get at the information you want to solve using the information you have. For example, density is equal to mass divided by volume. You need to be able to do the sorts of algebraic manipulations to turn that into mass equals density times volume, or volume equals mass over density. Remember, when you're doing algebra, it's kind of like conservation, only instead of conservation of matter, it's conservation of the 2 sides of the equation. Whatever you do to one side of the equal sign, you have to do to the other. For example, let's go ahead and see if we can't, collect our units. Find out what we're looking at in terms of x. 5x minus 3 is equal to 5 divided by x. A good way to simplify this, you have x in the divisor. That's unpleasant. Let's go ahead and get it out of there. Okay, it'll make things simpler. Do that by multiplying both sides by x. Remember, what you do to one, you do to the other. Multiply both sides by x, and the result, 5x squared minus 3x is equal to 5. Now, it should be more clear that what we're looking at is a quadratic equation. Let's go ahead and simplify things by getting it all on one side. Subtract 5 from both sides. When you do that, what you're left with is 5x squared minus 3x minus 5 is equal to 0. And that we would be able to plug into the quadratic formula and find the various values of x. I'm not going to do that. We'll talk about the quadratic formula another time. But it's not just algebra you need to focus on. You also need to be okay with arithmetic. You need to be able to work with derived units, multiplying, dividing, and so on, so that you can transform from one kind of measurement to another kind of measurement. For example, if something is falling at 9.8 meters per second squared, that's acceleration, and it does so over 5.25 seconds, how fast will it be going? So there's our measure of acceleration, 9.8 meters per second squared. That is to say, it is falling downward, hence the negative sign, and its speed is changing at 9.8 meters per second every second, hence meters per second squared. So we multiply that by 5.25 seconds. We have seconds squared on the bottom, we have seconds on the top. Seconds divided by seconds. Okay. One of those seconds will cancel, and our answer will be 51.4 meters per second. Now, I didn't worry about sig figs for this one. You have to. So, working with units is just like working with numbers. Okay? They're just another part of the measurement, another symbol, another piece of information that you can manipulate like anything else, adding, subtracting, multiplying, and dividing. 2 is the same thing as 2 divided by 1. Meters. You can think of that as the same thing as meters divided by 1. 3 divided by 2 is the same thing as 3 times 1/2. It's equal to 3 halves. In the exact same way, meters divided by seconds. That's meters times 1/seconds, or meters per second. You need to be able to manipulate numbers and units. But it's made a little bit simpler in that you can manipulate them all in the exact same ways. And when you multiply and divide and so on, units will cancel out in all the same ways that numbers will. For example, 3 times 2 times 7 divided by 4 times 6 times 5. Okay? Well, you can cancel out some of the prime factors there, right? 3 and 6 are both divisible by 3. 2 and 4 are both divisible by 2. And the result is the fraction 7 over 20. The exact same way, you can do the same thing with units. Kilograms squared times cubic meters times square seconds divided by meters times cubic seconds. Meters cancel out on top and bottom. Seconds cancel out on top and bottom. The result is kilograms squared times meters squared per second. It looks really different, but you can see it's the exact same kind of manipulation. You need to be able to work with units the same way you can work with numbers. This is going to be really important. And if you can get this, if you can do multiplication, division, addition, and subtraction with measurements and not just with pure numbers, if you can get accustomed to manipulating these things, it will make it a heck of a lot easier to do all the sorts of conversion and mathematical work we need to do throughout the semester. So remember, a measurement is a number in 3 parts. Okay, you have the units, you have the number, and you have the magnitude. And units are always part of that. You can't take the red off the apple. So you have to remember the units, and you have to move them around with the rest of the number whenever you're doing arithmetic or algebra. Whether it's a part of the number, like being positive or negative is part of the number. Okay? So whenever you move a measurement, you're also moving the units. You multiply, you divide, add, subtract. Move the units at the same time. And that does it for Chapter 1. Now, this chapter, even though it ramped up in difficulty a little bit there at the end, for those of you who don't like math anyway, this has been a fairly easy chapter. But don't let it fool you. This semester is going to get harder. With every chapter we do, you're going to have to do more and more work, and it's always going to expect you to have learned the stuff that came before. It's always building on what came before. So, that's it for Chapter 1. I'll see you next time.